This week in CIST 1520, we're going to look at tutorial 11, working with events and styles. In this tutorial, we're going to look at how to create an event handler, how to reference an attribute from a page element, create an inline style, change the inline style of the page element, create code for mouse events and keyboard events, look at design and apply custom cursors, also create and apply anonymous functions, and work with the alert, confirm, and prompt dialog boxes. All right, JavaScript programs, they run in response to events. Event can be defined as an action that's being initiated by the user or by the browser. Some examples would be clicking an object on a form, closing a web page. Throughout the chapter in the text, there is a puzzle that we'll be looking at in this presentation. So we'll still got some code here where they've got everything broken down in table headers. You can see that the column and rows are defined in the code, in the HTML code. So we're going to look at creating an event handler. All right, an event handler, it's a property that controls how an object will respond to an event. So the event handler waits until the event occurs, and then it's going to respond by running the function or a command block to execute the action. So we see the syntax of this. So we see the element on event and then the script. So in this case, the element is the element in which the event occurs. The event is the name of the event, and script is the commands that are going to run by the browser when it responds to the event. You can also define an event handler as an object. So we see the syntax of using an event handler as an object. It's object.onEvent equals the function. Okay, so in this case, the objects, that's the object in which the event occurs. The event's the name of the event, and then the function is the name of the function that runs. So looking at some examples of event handlers, for example, on cut is event handler that runs a script when the user cuts the contents of an element. On load is after the page is finished loading. And looking at the code for our puzzle, and this is applying the onHold event handler. So we see we have the object here, the onLoad event handler for the Windows object. So we have Windows.onLoad. So we're saying when windows are loaded, we're going to run the init function, the name of the function. And then we have the function developed here. So this is what will run when the window's loaded. And the output of that. So as you're working through the chapter, you will have to add an event handler to the buttons that was in figure 11-8, which are these buttons here. So you would add the onClick event handler. So what onClick does is it's going to respond to a mouse click. All right, so once again, we're setting this up. We have our object for this, and in this, we're adding an onClick. So the onClick is telling the browser, telling the JavaScript function that when this is clicked, perform this function. Let's see an example here. We have the puzzle buttons with the variable I, and we've attached the onClick event handler. And so when the onClick is performed, then it's going to run the swap puzzle function. So we're going to, in this case, swap puzzle pieces. Now, you do have a challenge in this of determining which button was clicked. So we can use event object to determine this. By using an event object, that's an object that contains properties and methods associated with an event. So the example we have here is when we click of a mouse button, it's going to generate an event object. It contains information such as which mouse button was clicked, where it was in the page it was clicked, time it was clicked, and so forth. The event object is passed as an argument to the function handling the event, and it's going to retrieve the information contained in the event object. So we see the example of the syntax with function, my function, and then the event. That's the names will be assigned to the parameters receiving the event object from the event handler. As we'll see in this screen here, different properties for event objects and their methods. So, for example, in the event.target, it returns the object in which the event was initiated. Event.current_target returns the object that is currently experiencing the event. Let's see an example of the code using the event object. So here we have the function swap puzzle E. Okay, so this is the event object for the event handler. The target's property is going to reference the button that was clicked. So you see here we have the variable puzzle ID, and it's going out and getting the ID for that button. So it's retrieving the ID of the button that's been clicked. From there, then we're going to have the puzzle title is set to the target value. And then it displays the puzzle based on the value of the puzzle ID variable in the switching case. When we talk about JavaScript properties, these are going to be mirroring the HTML attributes. And there are certain conventions that must be followed. For example, JavaScript properties must begin with a lowercase letter. Now, in HTML, when we had multiple words combined for the attributes, we use the camel case. So in JavaScript, we do as well, where the initial word's lowercase and the first letter of each word after that is going to be used in uppercase. If we have an HTML attribute that is named and it's a reserved JavaScript name or keyword, the corresponding JavaScript property is often to be prefaced with a text string HTML. Our class attributes is an exception to this convention because the class name is reserved by JavaScript for other purposes. And we references to the HTML class attributes use the class name property. And you see on the screen the class name. That's also an example of a camel case where the first word is lowercase, the second name, or the second word, in this case name, is capitalized. Okay, inline styles for properties or for page elements, they can be applied using this syntax, style attribute. So we have our element, which is the page element. The style is set to property, and then the value. Property is the CSS style property. Value is going to be the value that's assigned to that property. Now, when we look at this in JavaScript, the equivalent command would be object.style.property. Remember to write property styles written in camel case, capital letter for the first word, lowercase for the rest. I'm sorry, lowercase for the first word, capital letter for the rest. Inline styles are going to have precedence over style sheets as well. Keep that in mind. You can also use JavaScript to change the background color. You can, for example, you can apply the following CSS style rule for all the elements, the TD elements, when you're working through this. So we set up the table, the grid, and we change the background color to this RGB values. Now we can use JavaScript to change the background color of our table cells. But to do this, we must define an object collection based on the CSS selector using the following query selector all method. So we'd say document.query selector all, and then the selector. The selector is going to be the CSS selector. Okay, that's what our object collection is going to be based on. So then once the object collector has been defined, you can change the background color style of each of the TD elements. You can apply it by applying the background color property to the object in the object collector, and we will see this here. So you also only reference the first element that matches a selector pattern. If you want to do that, you only use it like this, the document.query selector and then the selector. Once again, that selector is going to CSS selector. All right, so we see an example of this here. So the first one, the puzzle cells equals document.query selector all. Then the table information here. This is the object collection. And it's going to apply to all the TD elements in the grid table. The next one is going to change the value of the background color inline style for each TD element to gold. So this is going to loop through. So it's going to go through every TD element. And we're changing the puzzle cells style background color, and we're changing the value there. So this screen here, this code here is just revising the init function. This is what you'll work through your chapter reading. JavaScript also supports mouse events. So this includes left clicking, right clicking, double clicking, moving the pointer over and out of page elements. We see in figure 11-17 the different events and the descriptions of those. For example, click, the mouse button is then pressed and released. The double click, mouse button has been double clicked. Mouse down is just when the mouse button is pressed. You can have these with the mouse over, so when you roll over an image or roll over an object, based on that action, some type of event can happen. Now, a mouse action can also be compromised with several events. For example, here, clicking the mouse button is compromised of 3 events. And these are in different order, are fired in the same order. You get mouse down, mouse up, and a click. So mouse down, the button's been pressed. Mouse up is when the button is released. And then click is where the button has been pressed and released. So those 3 events all happen when you click with your mouse. All right, so the event object for mouse events, they have a set of properties that can be used to give specific information about the state of the mouse. For example, the event property event.button returns a number indicating the mouse button was pressed, where 0 is going to equal left, 1 will equal the wheel or the middle button, and 3 maybe is equal to the right. And of course, the EVT is going to be the event object for the mouse event. The client X and client Y is going to return the horizontal or vertical coordinates for the mouse pointer relative to the browser window in pixels. Page X, page Y is going to return the horizontal coordinates and vertical coordinates, the mouse pointer relative to the document in pixels. And you have different event properties and their descriptions listed in figure 11-18. So in figure 11-19, we're looking at applying the on mouse down event handler. Okay, so we have the variable cell background. That's a global variable for storing the cell background color. So we're adding an event handler to every mouse down event. So we're saying on the puzzle cells for on mouse down, we're going to set the background. So this here is going to run the set background function, and it's going to happen every time the response to the mouse down event. So you see that the function background is that once this is run, we're going to set the background color style to the variable or to the value of the cell background variable, which is set here. Okay, an event model can be defined as it describes how events and objects interact within the web page and web browser. With this, the process in which a single event is applied to the hierarchy of objects is part of an event model. And once an event has been initiated, it propagates through the object hierarchy in 3 phases. We have the capture phase. It's where the event moves down the object hierarchy, starting with the root element, which is the browser window, and it moves inward until it reaches the object that initiated the event. The target phase is when the event has reached the target of the event object and no longer moves down the object hierarchy. And then we have the bubbling phase. That's the event that propagates up the object hierarchy back to the root element where the propagation starts. So you see in the figure 11-21, the event model, propagation and event model, as we start with the capture phase, move down to the target phase, and then back up to the bubbling phase. There are limits to event handlers, such as on-click and on mouse down, for example. They respond to events during the target phase. Okay, but they don't recognize the propagation of events through the capture or bubbling phase. And you can also only have one function can be applied to event handler at a time. So you can add an event listener that listens for events as they go through the capture, target, and bubbling phase. This allows the script to respond to an event within any phase. Also, with event handlers, you're going to have more than one function can be applied to the event using the event listeners. So we'll look at the syntax for adding an event listener. So we add an event listener to an object. We apply the add event listener method. All right, so we look at this object. In this is going to be the object from which the event occurs. The event is the event. The function is the function that runs a response to the event. A capture here is going to be an optional Boolean value, whether it's true or false. True indicates the function is executed during the capture phase. False, which is the default, indicates that the function is run during the bubbling phase. So we see an example of our code here, the document.add event listener. Okay, in this case, we've added mouse up. So it listens for the mouse up event to occur anywhere within the document. When that happens, it runs the end background function that's going to happen in response to the mouse up event. So this function will run when a mouse up is found. The end background will run when the mouse up happens. Now, the event model also allows you to remove event listeners from the document, and you do this by applying the remove event listener method. So same syntax, object. So this time we're going to remove it, event listener, and then the event function, and then the capture options as well. These object event function captions, they're going to have the same meaning as they did when we added the event listener method. So we'll look at the syntax for this. So in this case here, we're going to remove the event listener. That's going to run the extend background function in response to the mouse enter event. Now keep in mind the browser is going to have its own default responses to events. So if we apply the prevent default method to the object events object, it prevents the occurrence of the browser's default actions. As we see the syntax for the event dot prevent default. Now you can also prevent the browser's default action by returning the value of false from the event handler function. Now this doesn't work, it doesn't prevent default actions if the event listeners are used in place of event handlers. This example of code will prevent the default browser action of selecting text in the table. So we have the e.prevent default function. You can also work with keyboard events. So key down, key press, key up events. Those allow the users to interact with web pages and browsers through the keyboard. Key down is when the key is pressed down. Key press is the key is pressed down and released. It results in the character being typed. Key up is just the key is released. So the difference between key down and key press. So key down, key up events, they're fired in response to the physical act of pressing the key down and a key moving up when it's no longer held down. Key press event is fired in response to the computer generating a character. So remember, there are keys on your keyboard that you can press that do not type a character onto your screen. Now you can use properties in here as well, which is keyboard event properties. For example, the event dot control key. That will return a Boolean value indicating whether the control key was used in the event. We can do the same thing with Alt. Key code returns the Unicode character of the key that's used in the key press event. Meta key is going to return a Boolean value whether the meta key, which is the command key on Macs, or the Windows key on a PC, was used in the event, and so forth. Now the values associated with the key event property is affected by the event itself. All right, so the key press event, the character code, key code, and which properties are all returned for a Unicode character number. We're going to look at some samples of these in the next slide on figure 1129. Let's see example of the keys A through Z, A and Z, character codes, key codes, which keys were pressed, the key itself. So we see the different values of the key ups, key downs, and the key press listed in this figure here. Modifier keys are your Alt, Control, Shift, Command keys. Now, JavaScript does support the modifier keys, the use of the Alt key, Control key, Shift key, and Meta key properties. So looking at the code here for this, so we're saying at the first one, it says, if the shift key is pressed down, change the background to gold. So we're checking first in this, if the shift key is done. If not, we're looking to say, okay, if not, we're going to check the Alt key. If the Alt key was pressed down, we're changing the background to white. Otherwise, we're changing this background to gray. So if the function is ran and the shift or the Alt key was not used, we're going to have a gray background. You can also change the cursor style using the CSS cursor style. Cursor set to cursor types. Cursor types is going to be set to a comma separated list of cursor types. You could use JavaScript to define cursors using the object.style.cursor equals cursor types. In this case, object is going to be the page object that will display the cursor style when hovered over by the mouse pointer. You can use a customized cursor from an image file by using the URL image, where in this case, image is going to be the image file. So we'll see the example here. The URL is set to the jpf_pencil.png. Now, you see the second one in this where it's set to pointer. Okay, so this is what will be displayed if the use of the image file is not supported. By default, the click point for a cursor is located in the top left corner of the cursor image at the coordinates of 0, 0. You can specify different locations by adding the X, Y coordinates to the click point of the cursor definition. As you see here, the URL image, X and Y, that's going to be the X and Y coordinates, the click point in pixels. Okay, remember that everything that we work with in JavaScript is an object. That's including our functions. So whatever can be done with an object can be done with a function. This includes storing a function as a variable, or storing the function as an object property, using one function as a parameter for another function, nesting a function within a function, or returning a function as a result of another function. You can also modify the properties of another function. We're going to look at function declaration and function operators. So we got a hello function, and we're going to create this using the function declaration format. So in this we say function, keyword function, and then we're going to name it hello. And inside this we're going to put the alert. Welcome to Hanji. So in this, when this function is called, when we call the hello function, we will have an alert. We'll have a pop-up on the screen that will tell us, welcome to the game, welcome to Hanji. The function operator in this case, that's the definition of the function that becomes the variable's value, as we saw here. So we have the variable of hello, and we've set that to the function of welcome to Hanji. Now, both of those define the hello function, but it's going to differ in how they're stored. Functions stored within a function declaration are created and saved as the browser parses the code prior to the script running. In this case, the function is already stored in memory. The statements that run the function can be placed prior to the statement that declares the function. Function operators are evaluated as they appear in the script after the code has been parsed by the browser. Function operators are more flexible than function declarations. They allow a function to be placed anywhere a variable can be placed. We also have to talk about anonymous functions. Anonymous functions are function declarations without the function name. So we see this following syntax: the function commands. That is an anonymous function syntax. They can be inserted into any expression where the function reference is required. Functions that are named are called named functions. Now, with this, we got to keep in mind that anonymous functions are more concise. They're easier to manage simply because the function is directly included within the expression that invokes it. They do limit the scope of the function to exactly where it is needed. So we'll see an example here. So we have this event listener that's clicked, so it's listening for the show solution button to be clicked. When it is clicked, this function is going to run. So we added the event listener solve. It was listening for click, and when it's clicked, this is ran. So this is going to run exactly when this. So you notice it does not have a name for this function. This is an anonymous function. Now, JavaScript is going to support two types of variables. You have your global variables and your local variables. Global variables are going to be declared outside of any function, and then they are accessible throughout the app. Local variables are declared within a function, and they're only accessible to code within that function. Global variables should be avoided when possible because they do have they are accessible to every function in the application. And then the task of tracking which functions are using and modifying the global variables becomes increasingly difficult as your application grows in size and complexity. So this is another reason that you have an advantage of using anonymous functions. They reduce the need for global variables because they're able to perform their actions locally within the function. One of the challenges of anonymous functions, though, is keeping track of all the nested levels of functions and their procedures. So see, we got the set timeout method. We're using an anonymous function. After a 5-second delay, it will run the set timeout. In this case, we're removing the hints. And we're going to set the delay in milliseconds. All right, as I mentioned earlier when we saw the alert with the welcome message, these are dialog boxes that can be created using the alert method. So you have the alert and then the text. That's the text message that's going to be displayed. Now with this, when it's displayed, the alert box, the execution of the program is going to be halted until the user clicks the OK button in the dialog box. See some examples here. So we have the dialog box of alert text, which displays an alert message. As the example we had, alert, welcome to Hanji. So this is what we'll see. The program will not be executed until we click OK. We have the confirm and then the text. So in this case, I got the variable quit game is equal to confirm and then the text to quit the game. You can also display a prompt box that prompts the user to input text. As we see, the example here is the variable game type is set to prompt. Enter your game and then Hanji. So in this, the user would enter their game, maybe put your name in the game. If the cancel button is hit, a value of null will be returned. So in this case, they applying a confirm dialog box. So we have the function. So we're saying if we're going to ask for the confirm. And we're going to tell them that you will lose all your work on this puzzle, and then ask them to continue with a yes or no. In this code is only going to be ran if the user clicks OK in the confirmed dialog box. If not, it's going to cancel out. Be sure to close your statements with the curly braces as well. So we have an event handler happening here that once the puzzle is completed, we will have an alert telling the user that they have completed the puzzle.